Yes, sir.
Yes, sir.
Yes, please, sir.
Hope everything is in order today, Kamachi.
Yes, sir. Very much, sir.
No problem to stop at 40 minutes or 50 minutes. Okay.
Yes, sir. Absolutely all right, sir. Thank you, sir. We can start, sir.
So we have the one leftover topic from last week about oxygen supply. What is the normal oxygen supply for small hospitals or earlier, even in big corporate hospitals? How many of you have seen a manifold room? Hello?
Yes, sir.
Yes, sir.
Any of you have gone and seen your manifold rooms where cylinders are stocked?
No, sir.
No, sir.
Banks. Okay.
No, sir.
Oh, I think you should make an attempt to go and see, learn about the manifold room also. Because in manifold room for larger hospitals where there is a large demand for oxygen, oxygen is transported in large cylinders called G cylinders or J cylinders, which have the maximum capacity. And these cylinders are stacked in rows of 5s or 10s on one side, and similarly on the other side, and interconnected. And these cylinders will be called as running bank and spare bank or storage bank. So automatically, once all the cylinders in the running bank get exhausted, the storage bank will start supplying. Automatically, a valve will open and the pressure drops and start supplying. So there is no interruption in the supply of oxygen. And then there will be a warning signal or a light visual alarm to say that the bank is empty, and that will caution the people to change the empty cylinders into filled cylinders. So it requires a lot of manual labor as well as transportation of these big cylinders, get them refilled and all that. So in order to overcome this problem, people thought of supplying the liquid oxygen to the hospital. As you all know that in normal conditions, oxygen cannot be liquefied like your nitrous oxide. What is the reason for that?
The critical temperature is
Critical temperature is very, very low. Okay? So it is running in minus. So it cannot be compressed that easily into liquid form. So we are going to see how the liquid oxygen is prepared, manufactured, transported, and supplied to the hospitals, and where it is stored in hospitals, and how do you know how much is there in the cylinder or in the tank. It is not called the cylinder, it is called the tank. And how that liquid is getting evaporated and comes out as a gas for usage, and what are all the advantages and disadvantages of this particular system. We are going to learn that today. As usual, it will be in the form of question answers. So if you know the answer, you can tell, otherwise the answers will appear within a few minutes. Okay? So without wasting time, I will go to share my screen. Hope it is visible.
Yes, sir.
Okay. So the first thing we have to know is how is liquid oxygen manufactured? Any idea? Does it require any raw material like the earlier days when they used to need the chemicals and the reaction from the chemical to release the oxygen? Original identification of oxygen was from which chemical? Any idea? So liquid oxygen is made from the atmospheric air. That is, you don't require any chemical or anything for that. All you need is the atmospheric air only, because atmospheric air contains oxygen and nitrogen. So if you remove the nitrogen from the atmospheric air, you get the oxygen. Will you get pure oxygen from that? If you remove nitrogen alone,
No, sir.
there will be
It will come.
what are, there will be very minor contamination with other gases like argon, xenon, etc. Okay? So the process of manufacturing liquid oxygen is known as separating by the oxygen in the atmosphere by a process called fractional distillation. Because these gases have different boiling points. So that is the basis of the manufacturing of liquid oxygen. So for that you have to first compress and cool the atmospheric oxygen. So the process of separating atmospheric oxygen is by distillation, and it consists of two main phases. One is you have to make the air itself into a liquid first, and then you have to distill the liquefied air into its components. So the fractional distillation of air involves first cooling and compressing the air into a liquid and separating it into its main component gases, namely oxygen, nitrogen, and argon. These are the three major components. Argon, of course, is very, very small component. So first thing, before cooling and compressing the air is filtered and all the impurities are removed, and then it is cooled up to minus 200 degrees centigrade. That is the temperature it is cooled to. And as you do this cooling at minus 79, whatever carbon dioxide is present in the air will freeze, become a solid, and it will be discarded at this point. And then oxygen will be liquefied at minus 183 centigrade temperature. So when you cool it to 200 degrees, the liquid air, which is now free of carbon dioxide. Carbon dioxide has become already solidified, freezes and removed, passes into the bottom of a fractioning column, which is warmer at the bottom. That means it is more 185 degrees than at the top, which is 195. So top is more cooler compared to the bottom. So minus 185 is less cold, whereas minus 195 is more cold. So that is why it is called warmer at the bottom. And the liquefied nitrogen, which liquefies at 195 degree, boils and returns to its gaseous form and exits through the top of the column, leaving the liquid oxygen and argon. So these two gases, this is called the fractional. At each point, a fraction of the component is removed. That is the reason why it is called the fractional distillation. So carbon dioxide freezes and becomes a solid and it is removed, whereas nitrogen becomes a gas and it is escaping from the fractional distillating column. And to remove the argon, because both have similar boiling points, another fractioning column is used to remove the argon, and finally you get a pure 100% oxygen, and that will have a pale blue color. So the liquid oxygen is not white, it is a pale blue liquid, which is cooled at minus 183 degrees centigrade at 1 atmospheric pressure. And it is either delivered as a cryogenic liquid system or as a liquid cylinder installation. So for all the hospital use, what you see in your hospitals will be the liquid cylinder installation, whereas larger units where you require more usage, that will be in form of cryogenic liquid system. Now coming to this picture will tell you, the first air from the atmosphere is drawn in, it is cooled, and it is solid and carbon dioxide. As you cool, this carbon dioxide is removed once it freezes at minus 79 degrees centigrade, and then it becomes a cold liquid at minus 200 degrees centigrade. It is pumped into the fractioning columns. Okay? And as the at various boiling points, you can see the xenon and krypton move out at 154, oxygen at 189. So like that, they will all separate as a separate liquid and then come out, and nitrogen will be alone removed as a gas at 196 degrees. So How is it stored? Once you get the liquid oxygen from the liquid air, after removal of all the other components, how do you store this liquid oxygen? It is stored in the bulky tanks what you see in your hospitals. I think in Miyot it is situated on the right hand side of the emergency department,
Yes, sir.
near the parking lot. Am I right?
Yes, sir. Yes, sir.
Yes, sir.
I have seen it whenever I come to take class in person those days. And that is what is called the VAE, or the vacuum insulated evaporator. So that terminology itself will tell you the mechanism of action, how this storage tank works. It is a vacuum insulated to protect the temperature, because the liquid inside is at a very low temperature, minus 183 degrees. And that has to be maintained. Otherwise, it will all become a gas and it will develop enormous pressure and explode. So, it is very important to maintain that temperature. And whenever the requirement is there, just like your nitrous oxide cylinder, where the liquid is at the bottom and gas is on the top, the same way the gaseous oxygen will be at the top, which will be drawn out to supply to the required areas. So this itself, this vacuum insulated evaporator itself is sometimes asked as a short note question. Can any one of you describe what it is made up of? What is the material it is made up of? This tank, storage tank. Did you all read about this?
Awesome.
Double wall steel.
Hmm?
Double
Is it a
wall
single
steel.
walled tank or a double walled tank?
Double wall.
Double wall.
Double walled tank. So what is the outer wall made up of? What is the inner wall made up of? And what is there in between the two walls? It is just like your thermos flask. What you have read in your school days, how the thermos flask retains the temperature, the same mechanism but of different material. Okay? So it's a double walled large insulating flask. The inner wall is made up of stainless steel and the outer wall is made up of carbon steel and casing by so carbon retains more heat or cold, whatever you store in that, and it does not transport the heat or cold much faster. So that is the reason why it is made up of two layers. One is inner stainless steel layer to give purity without contamination, and outer is the carbon steel casing, and they are separated by a layer of what is called perlite, which is an insulating material and high performance of vacuum at 0.16 to 0.3 kilopascals. So the liquid oxygen, the storage, it may be up to 1500 liters. The tank may contain up to 1500 liters inside the container at minus 170 degrees, much lower than the critical temperature of minus 118 degrees centigrade, and at a pressure of 10.5 atmospheres. So these are the characteristics of the tank or the storage, where you can store up to 1500 liters and the inside temperature is minus 170 degrees and the pressure inside the cylinder is about 10.5 atmospheres. So the liquid oxygen sits at the bottom, or it is at the bottom of the tank, and the gas sits at the top at a pressure of 10.5 bars. So this picture will tell you this is the liquid oxygen, and the evaporated oxygen vapor is there at the top, and it will get relieved at that through this point. And there is also a heating element, and there is situated on a tripod weighing function. As you all know that the quantity of the gas is, cannot be measured using a pressure gauge whenever the gas is compressed into a liquid form. So the only method, whether it is even the exam, they will ask you, your pressure gauge in oxygen cylinder will tell you the amount of oxygen using the simple gas law. Which gas law is employed to find out the remaining quantity of oxygen in a cylinder which is fitted to the machine? Boyle's law.
Boyle's law.
So remember that. Boyle's law is the one which is used to calculate the remaining gases using the pressure reading in the pressure gauge of the oxygen cylinder. Whereas for nitrous oxide and liquid oxygen, you have to weigh the cylinder to find out the balance quantity. You cannot find out from the pressure gauge because it will read the same until the last drop of the liquid evaporates and becomes a gas. Then only the pressure will drop. So the weighing is important. So the whole tank is fitted onto a weighing scale, and that will show the balance amount in that, which will help you to see whether this tank has to be refilled after all the gases have been utilized. So this is how the whole circuit works. So this is the steel, stainless steel. Outer is the carbon steel, and in between the perlite vacuum is there, and the evaporated gas goes out through that. And there is a pressure release valve because the pressure inside is so high. Supposing excess of gas gets vaporized into gaseous form, in order to prevent an explosion or damage, there will be a relief valve, pressure relief valve at 7 atmosphere that will cause a relief. And there is a control valve to see what is the amount that is required. And there will be a lot of pressure regulating or reducing valves, just like your boils machine, before it is let out to the atmosphere at 60 psi pressure, or what you want to use in the OT or ICU. Okay? So the temperature of the vessel is maintained by the high vacuum shell, and the gaseous oxygen above the liquid pass through the superheater to raise the temperature to ambient outside levels, and it then flows into the pipeline, giving a continuous supply. And the escape of gas into the pipeline system prevents the pressure inside the container from rising to abnormal levels. And in case if the pressure rises too high, there will be a safety valve in this is the safety valve. So this will immediately release the excess pressure and prevent the explosion that is occurring. And if the pressure in the vessel drops due to cooling or some other increased demand and drawing the vapor at faster level, then liquid oxygen can be drawn and passed through the evaporator and return to the gaseous form to restore the pressure, so that there is no discontinuity in the supply of oxygen to the needed places. And there are uninsulated coils of copper tubing which passes through a series of pressure regulators. So from 10.5 atmospheres, ultimately the distribution pipeline pressure is only 410 kilopascals. So it is reduced using the pressure regulator, just like in your anesthesia machine, so that abnormal high pressures are not delivered and barotrauma is avoided. And the storage vessel rests on the weighing balance, which measures the mass of the liquid, which will tell you the content, so that it will give an indication when to refill it and maintain the supply. And nowadays, instead of this weighing scale, there is a differential pressure gauge which is used to measure the pressure difference between the bottom and the top. And that also will tell you about the storage level of the liquid in the tank, with which you can again order for a refill. So one volume of liquid oxygen, it will yield 842 times of its volume of oxygen in gaseous form at 15 degrees temperature at 1 atmospheric pressure. So this is the conversion. So if you take say 1 ml of liquid oxygen, it will become 842 ml of oxygen gas at 15 degrees temperature. That is half the temperature of a room. Nowadays, you know that summer we have 34 to 39. So at 15 degree temperature, we almost form 842 times. So what are the benefits of liquid oxygen? Why the hospitals prefer that? It requires less space. And see, for example, as I told you, if you go to the manifold room, there will be 10 cylinders on one side for oxygen, 10 cylinders for nitrous oxide, and you will have to have another storage space for the empty cylinders and refill cylinders and all those things. So it occupies a lot of space. Whereas this tank can be fixed in a, say, at the most 50 by 50 area. And it is easier to store and transport, and it is beneficial in hospitals where space is limited, and the purity of liquid oxygen is uncomparable. So it is the most pure form of oxygen, which is critical in medical applications, because this sort of process of fractional distillation and oxygen is used for industrial purposes also, where they don't make much attempt to remove the argon and xenon. Some amount of purity is accepted there, whereas for our medical usage, it has to be 100% pure oxygen. So the purest form of oxygen you get only from liquid oxygen. And it has a reliability and a long shelf life. And storing oxygen in liquid form is more cost effective than using compressed gas cylinders. So cost wise also it is much cheaper. And how is the filling of the oxygen tank done? Have any of you noticed the liquid oxygen transportation tank coming, the lorries coming and fitting and filling that? Anybody has noticed or not seen? Okay. So the tank is usually refilled by connecting a hose from the liquid oxygen supply tank, which is brought in lorries, and it is connected to that, just like the petrol stations fill their petrol tanks. You know, the underground petrol sumps will be filled with the hose in the petrol stations. Just like that, this liquid oxygen also will be brought in tanks, and then there will be a huge hose which is connected to the receiving VAE tank, and then it will be filled. And once you achieve the required weight, they will stop, and then you have to close all the valves and make sure that what precautions you have to follow while refilling. So you can see this picture. This is the tank which is the VAE flask, and you can see there is a pressure gauge. This is the supply coming from the form of a lorry bringing this tank, and you can see the hose going in and then filling it into the tank up to the desired level, and the weight will tell you how much has been filled, and once the required weight has been achieved, that is up to 1500 liters have been filled, you just stop there and then disconnect the hose and they go back. So this is how ensure that the VA tank is clean and dry. Make sure the connection points between the supply tank and the VA tank are clean and secure. Connect the transfill hose to the supply tank, usually the largest stationary VA tank. This is the oxygen tank, and this is the supply tank. And slowly open the valve on the supply side to allow the oxygen to flow into the supply line. And then slowly open the valve on the refill cylinder to allow oxygen to flow into it. Monitor the pressure gauges to ensure that the cylinder is not overfilled, and wear appropriate safety equipment such as gloves, eye protection to prevent burns from cold temperature. So if you come into contact with that such high 170 degree minus 170 degree liquid, you will get blisters and you will get something like a frostbite. So this can cause frostbite and burn. So once the tank is filled to the desired level, close the valves on both supply tank and refill tank, and disconnect the whole thing. And the tap point should be securely closed after that, so that no leak occurs. And this is another close-up view of the tank like that. You can see all the pressure gauges and connections and outlet lines are all there. And again, this is a simplified diagram given the World Federation of Society of Anesthesia article, where you get this very simple diagram of liquid oxygen. The temperature minus is some books say minus 170, but some books say minus 180. This is a common question they ask you in the exam. what is the temperature in the VIE inside? It is minus negative 180. And this is the pressure gauge, and you can see the pressure inside is 10 bar, and safety blow off valve at 17 bars. And then this is the control valve. And this is the vacuum between the two layers of the flask. And there are heater coils to vaporize this liquid. In case it is flowing as a liquid, it will be converted into gas, and ultimately it is delivered to the pipeline. And here, of course, what is missing is the pressure reducing valves. They have not drawn that, but a series of pressure reducing valves will be there to bring down the pressure to the usable level. So that is the description of the liquid oxygen and the details that you have to know from practical point of view as well as from exam point of view. Any doubts on that? Any questions you want to ask?
No, sir. No, sir.
No. Okay. Now we will go to the next part of the same oxygen supply, which is oxygen concentrators. After the COVID, all of you might be aware that the patients have been asked to continue oxygen therapy sometimes at home because of the slow recovery of the lung after the infection. And just for the oxygen therapy, we do not allow the patient to stay in the hospital and occupy the beds where more critical patients will be seeking those beds. So the oxygen concentrators have been in use for a long time, even before COVID. Who are the patients who required oxygen concentrators? Where is it used actually?
In disaster management.
It is mostly for patients who are at home, domiciliary therapy, not for anesthesia. It is for patients who require oxygen therapy at home. Earlier to the invention of oxygen concentrators, we used to get oxygen supply in small cylinders, portable cylinders, what we call the B-type cylinders, with a connection to with the connecting hose and the face mask or the oxygen prongs attached to that. And there will be a key to open the cylinder, and there will be a pressure gauge to measure the pressure inside the cylinder. And there will be a flow meter attached to the cylinder itself. And you can adjust the amount of oxygen that is required from 1 liter to 10 liters. That flow meter will be able to supply. So that was the, and there will be a trolley to push that cylinder wherever you want. The advantage of this particular system is it is mobile, can be taken to any room inside the house or ward, wherever you want. And it doesn't require any electrical supply or this thing like your oxygen concentrator. But the problem is it requires somebody to open the cylinder and then monitor the flow and then close the cylinder. All these things have to be done properly, otherwise there will be a lot of leakage. And you have to keep on replacing those empty cylinders on and off if the usage is high. On the contrary, the oxygen concentrator again functions on the same principle of manufacture of liquid oxygen. But the oxygen is not liquefied like what you get in liquid oxygen. Here it is still in the gaseous form. And the same atmospheric air only is used for manufacturing oxygen in the oxygen concentrator. So the difference between liquid oxygen and oxygen concentrator is both, and the similarity is both of them are using only atmospheric oxygen for extracting the oxygen from the atmospheric oxygen. Whereas in the liquid oxygen, it is cooled, compressed, and then distilled to remove the other components, and you get the oxygen. Whereas here, it is in the gaseous form, and the removal of nitrogen, which is the same principle, is done by another technique. Can anyone of you tell me what is the technique called?
Pressure swing absorption.
Very good. It is called pressure swing absorption. Okay. And what do you mean by that? Pressure swing absorption.
It actually O2 concentration increases by absorbing the nitrous into that A nitrogen in
So you use a chemical to absorb the nitrogen. Okay. So if you pressurize the gas and use a chemical which will absorb the nitrogen, the remaining will be oxygen. And you don't take much pains to remove the small quantity gases like argon and xenon and all those things. So the oxygen you get here is only about 95% of purity. It may have some contaminants like the other thing, but they are harmless. So you can still have a adequate supply of oxygen. So this device supply oxygen to a single patient or can be used for medical pipeline system also if you may use it for a larger hospital. And the component systems are there is a compressor and a molecular sieve and receivers and dryers, vacuum pumps, filters, line pressure regulators, control system, oxygen performance monitoring system, and backup cylinder manifold. All these things are the components of oxygen concentrators. And it works on the principle of absorbing other gases in the atmosphere into the surface of an absorbent material known as zeolite. So the material here used is called the zeolite. And when you expose the zeolite to compressed air, the nitrogen alone will be absorbed by this zeolite. So the rest will be oxygen because the composition is also mostly 80-20%. So oxygen is not absorbed by the zeolite. So it passes free through into the storage for use. And it is hydrated, zeolite is a hydrated aluminum silicate. And it's an alkaline earth metal in a powder or granular form. And the zeolite is sealed in a vessel known as sieve bed. And the sieve beds operate in pairs. That is, we have two cylinders or sieve. I'll show the picture later. And one absorbs and the other regenerates to receive more and more nitrogen. So ambient air is filtered, pressurized to 137 kilopascals by a compressor, and then exposed to zeolite molecular sieve column, forming a very large surface area at a certain pressure. So the sieve selectively retains nitrogen and other unwanted components of air, and these are released into the atmosphere after heating the column and applying a vacuum. And the changeover between the column is made by time switch. Told you there will be two cylinders like that. So one will be in use, other will be spare, waiting to regenerate and act on the requirement. And this process is capable of producing oxygen. Purity is only about 95% because all the components and the minor components are not totally removed from that. And the remainder is made up of mainly argon, which is a small percentage of nitrogen. And so this is the picture of the outside of the unit. Majority would have seen, all of you have seen that. And it is a portable unit with a wheel. You can take it anywhere. And this is the electrical connection plug. You can see that the wire is there. It can be attached to that. You require electricity for this particular machine to happen. And some of the modern machines have battery backup, just like your anesthesia machine having a battery backup. Up to 3 hours, even in power cut situation, it can still function. And inside that you have all the parts, and you can see this is the flow meter, which you can adjust with the knob, and you can see the oxygen delivery prongs with the tubing which is attached to the. There is a water column to humidify that, and the gases flow through that, and we can adjust the flow in the flow meter here. And there is an on-off switch, control switch on the front side. And so you can see this is the air from the atmosphere is first filtered with a dust filter, and there is an oil-free air compressor which compresses the gas, and there is a heat exchanger because once you compress the gas, there will be a lot of release of heat, and that will be removed, and moisture is also separated and made it into a dry column. And you have these zeolite filters here. There are two filters that are interconnected. So the gas will flow through this, and all the nitrogen will be absorbed in this, and then it will go out, goes to the orifice, and there is a storage here inside the machine to store that, and then from that it is released. There's an oxygen analyzer to see the purity of the gas, and there is a bacteria filter also before it comes out, and there is a humidifier bottle, and there is a flow control knob, and this is how the whole circuit diagram tells you what is being done here. So the advantages of this is again a portable machine, and it supplies fairly acceptable purity of oxygen, and it is available for a single patient use as well as for hospitals with a minimal requirement. Cannot of course apply to a large institutions, and it is quite affordable also. The cost of the machine is about 35 to 40,000 rupees, and more expensive models are also there, but the basic model available up to 40,000 rupees, and some people also rent it out. If you are going to need it only for a short duration, you need not buy the machine. It is available for daily rental basis also, and so this is the mechanism of usage of oxygen concentrator. Okay? So these are the two sources of supply of oxygen about which you have to know. And I think that will be the, we'll stop there at the oxygen level. So next topic is pacemakers and ICDs.